All right, so first problem we're looking at today, we're given a graph of a function, we're given a chart of values for that function. It's a rate of fuel consumption, and we are looking to approximate, and it may be hard for you to read that, but that's R prime of 45. So we're looking for R prime of 45. I'll let you guys take a minute to think about that, and then we'll talk about it in just a bit. It's actually a really quick and easy problem, but I want you to think about it for a second before I just tell you what to do. So take a minute and think about that. All right, so we are looking for an approximation for R prime of 45. This is one of the College Board's favorite, very easy types of questions to ask. So they're giving us a chart of values, and we want to estimate or approximate the instantaneous rate of change at 45, yet 45 is not on our chart, right? It's between 40 and 50. So if we're going to approximate the instantaneous rate of change, what do you think the best way to approximate an instantaneous rate of change is?
Find the slope.
Find the slope, find the average rate of change between a set of points that are very close to that. So all they're asking us to do here is approximate that instantaneous rate of change by using an average rate of change formula. So 55 minus 40 or 50 minus 40, or just 15 over 10, or 3/2. And then if R of t was in gallons per minute, what should the rate of change of that be? It should be gallons per what?
Gallons per minute.
Well, R of t is already gallons per minute. So for
minutes squared.
Minutes squared, gallons per minute. Yeah, gallons per minute or gallons per minute squared, either one would be acceptable units for that. Note that it says down here indicates units of measure, so make sure that you do that when you get to the AP test in a long time from now. But if it tells you indicate units of measure, there is specifically a point associated with having the right units for that problem. So don't forget to put the units. You should always put the units, even if it doesn't say to indicate them. But you can be guaranteed there's a point associated with it if it says indicate units of measure. Easy one. Anytime it asks you to approximate a derivative and they don't give you an actual function to take the derivative with, just find an average rate of change on the smallest interval that surrounds that point. All right, here's another nice easy one that we're going to do. I'll give you guys a minute to look at that one and think about that one and see if we need all of the information that's sitting there. So I'll give you a minute or two to think about that and try and find an answer. So we're given the function, and all we're asked about is the limit as x approaches 0 from the right of that function. Is the derivative of this necessary information?
No.
No, we don't even need this. Now, they may, on the AP test, give you just unnecessary information sometimes, or they may give you this information, and then later on in a problem, they might require to use that. But it's important that you can weed out what's important and what's not important. So we don't need to worry about what the derivative of this function is at all. All we care about is what's the limit as x approaches 0 from the right of f of x. And so if we do that, that's the limit as x approaches 0 from the right of natural log of x over x. And so I think one of the reasons they might ask you a question like this is to see if you can differentiate between when you need to use L'Hopital's rule and when you do not need to use L'Hopital's rule. So this looks like one that you might want to use L'Hopital's rule for, but if you plug in 0 as natural log of x approaches 0 from the right-hand side, what is the numerator equal to? Right, here's your natural log. Yeah, negative infinity. There's your natural log function, basically, right? As we approach 0 from the right, it goes down to negative infinity. And then that's divided by x. Well, what's x approaching? X is approaching 0 from the right. So what do we have down here? We have a very small positive number, don't we? And if I have a very large negative and I divide it by a very small positive, when you divide something by a very small number, what happens, something that's less than 0, what happens to the number? It gets even bigger, right?
Yeah.
So this is actually not a L'Hopital's rule problem. So be careful with that, because if you try to use L'Hopital's rule, you're going to end up getting a different answer. But the result for this should be negative infinity. What would happen if you tried to use L'Hopital's rule? You'd end up with 1 over x. In fact, let's write this out. I will make the caveat that we shouldn't be doing this. Don't use L'Hopital's rule for this one. But if we were to try to, what would we get? We get 1 over x over 1. And what would that give us?
Infinity.
It'd give us a positive infinity, and we do not want that, right? This was not infinity over infinity, and it was not 0 over 0. It was an infinity over very close to 0. Right? So this, not good. Everybody good there? Everybody good with that?
Yeah.
Not being good?
With L'Hopital's rule, can it only be used when it's 0 over 0, or like other indeterminate forms like infinity over infinity and stuff like that?
0 over 0 and infinity over infinity are the only two forms that you can use it for. It has to be 0 over 0 or infinity over infinity.
Are there other indeterminate forms?
There are a lot of other indeterminate forms. There's like 0 to the 0, 1 to the infinity, infinity to the
Okay, cool.
0 to the infinity. There's infinity minus infinity, a bunch of other assorted forms, all of which generally can be algebraically rearranged and converted into a 0 over 0 or an infinity over infinity. But that's not a Calc 1 topic, that's a Calc 2 topic. So for those of you that decide to take BC next year, if you're a junior, or Calc 2 in college, if you're a senior, you'll see those indeterminate forms. They get quite a bit more complicated. So just be aware of that, for those of you that are continuing on in math. All right, let's see here. Let's do this one next. I'm going to go slightly out of order. I'm going to skip to page 4 because the third one's going to take a lot longer. So we'll do this one next. So we've got an implicitly defined equation here. X squared plus xy plus y squared equals 27. And we want to determine if the lines tangent to the curve at the x-intercepts of the curve are parallel to each other, and then show our analysis that leads to our conclusion. So I'm going to give you guys a couple of minutes, probably 4 minutes or so. 4 or 5 minutes ought to be more than enough for that, I would hope, but I'll check back in a couple. So give this a shot and see what you come up with. All right, so we've got the curve x squared plus xy plus y squared equals 27. And we don't really need to know what that looks like to be able to solve this problem. It happens to be an ellipse that's been rotated a bit. It's not straight up and down or straight and horizontal. But that's not super important to this problem. We want to determine whether the lines that are tangent to the curve at the x-intercepts of the curve are parallel. So first off, we're interested in the points which are x-intercepts. So that's the first thing we need to do, is figure out what are the x-intercepts. That'd be step one, right? How do we figure out the x-intercepts of any equation?
Plug 0 into
Plug 0 into which value?
y.
Right, y, right? When y equals 0, that's when we have x-intercepts. So this will become x squared plus xy, which will be 0, plus y squared, which will be 0. X squared equals 27, so x is positive or negative root 27. And root 27 is 3 root 3 if we want to simplify that radical. So hopefully you all got your two x-intercepts, 3 root 3 and negative 3 root 3. Everybody good with that?
Yeah.
Yeah.
All right, perfect. Then we want to know if the tangent lines to the curve are parallel, which means we need to figure out the slopes of the tangent lines at each of these points. So we need to find the derivative. We need to find dy dx. So what does dy dx equal? Well, derivative of x squared with respect to x is 2x. The derivative of xy requires the product rule, so that'll be plus x times the derivative of y with respect to x, plus y times the derivative of x, which is just 1. And then plus the derivative of y squared with respect to x, which is 2y dy dx. So we need our implicit differentiation skill here, and equals 0 because the derivative of a constant is 0. Everybody good?
Yeah.
I shouldn't write a dy dx there at the beginning, but looking for dy dx, right? So now we'll solve for dy dx, which gives us, we can subtract the 2x and the y to the other side. So dy dx is going to equal negative 2x minus y all over x plus 2y. Is that the derivative that you all got?
Yeah.
It's possible
Yeah.
that you might have gotten 2x plus y divided by negative x minus 2y, but either way, those are equivalent to each other. I should factor the negative out of this or the negative out of the other one, and it should work out and look exactly the same. Okay. So now we need to figure out what is that at the point 3 root 3 comma something and negative 3 root 3 comma something. Well, what are those values for y? We should know.
0.
Should be
0.
because those were our x-intercepts, right? So any y values are going to be zeros, and we'll plug in our x values. So at 3 root 3 comma 0, what's our slope? Negative 2 times 3 root 3, so that'd be negative 6 root 3 over 3 root 3. And so what does that become?
Yeah.
Becomes negative 2.
Uh-huh.
And for the other one, for negative 3 root 3, we got negative 2 times negative 3 root 3, which is going to be 6 root 3. And the denominator is going to be negative 3 root 3, which is negative 2. Slopes of the tangent lines are the same. And so we would say, yes, they are parallel. Any questions or issues with that? That's something that might show up in a free response question. So I know we haven't talked a lot about the format of the AP test, but assuming it's a regular AP test this year, there'll be 30 non-calculator multiple choice and 15 calculator multiple choice questions. And then there will be 4 non-calculator free response and 2 calculator free response. So this would be one part of one of the 4 non-calculator ones. All of the free responses are worth 9 points each. So this might be like a 3-point part of one of the 9-point non-calculator questions. And the assumption is that you'd be able to do each non-calculator free response in 15 minutes. So this is probably, they don't specifically give you a time amount for each problem, but they would say this should take you no more than 5 minutes, probably a little less than that, if you were on the AP test.
How long do you
Yeah.
have for the multiple choice in, like the multiple choice section?
Yeah, so I believe, let's see, I would have known this if we'd done it last year, but now I believe it's still an hour for the 30 non-calculator multiple choice and 30 minutes for the 15 calculator multiple choice. They just changed that a couple of years back. So I'm pretty positive that's right. It should be an hour for the 30 and then 30 minutes for the 15 calc ones. And then you get an hour for the 4 non-calculator free response, and you get 30 minutes for the 2 calculator free response. But that's all a long way off. Not a lot to stress about there yet. All right, we're going to do one more, and this one's actually got all 4 points of it, and this one is a graphing calculator question, so you're going to want to get your graphing calculator out. Now, all of this instruction at the top is mostly just about, these are like the instructions you would normally see at the beginning of the calculator section of the AP test on the free response. So maybe read through it just so you've seen it before. But I'm going to give you guys, I don't even know, maybe, well, this is a full question. So I think if I give you guys 15 minutes to get through all of this, hopefully you can do that. Now, we haven't done a lot of these style questions yet. We've just been focusing on how to take derivatives and all that. But I am hopeful that you will be able to do some of this. And the more we go through it, the better you'll get at it, and the more problems like this we do. So I'm going to give you guys 15 minutes to work on this. So at 11 o'clock exactly, we're going to come back and start talking about all of these. Sound good?
Yeah.
Yep.
All right, ready, go. All right, so for the first one, we want to find f double prime of e to the 1.5 power. And it says to express your answer as a decimal approximation. So since this is a calculator problem, and we're already given f prime, to find the derivative of f prime at a certain value, we can just go in and use our calculator to evaluate the derivative of that function at e to the 1.5.
Could we just do it by hand if we wanted to? Like,
you could do it by hand if you wanted to, but I wouldn't recommend it just because, it's not that bad. It's x times cosine of x squared times 2x plus sine of x squared, and then you got to plug in either 1.5 to that. But if you just use your calculator, it's just going to tell you. So if it were me, I would just use your calculator. I would say something like this: the derivative with respect to x of x sine of x squared evaluated at x equals e to the 1.5 is approximately equal to. And then I would just go straight into my graphing calculator and I would just plug it in. I would do math, option 8, derivative with respect to x of, and now I don't remember what that function was. What was it? Was it x squared sine of x squared or just x sine of x squared?
X sine of x squared.
Okay, x, and then sine of x squared. And what was the x value? E to the 1.5.
E to the 1.5.
So e to the 1.5. Does that look like that? That looks like the right function, right?
Yeah.
All right, and I'm just going to make sure. Okay, I was in radians, so that's good. So 14.144. Is that what you guys all got or no?
Yeah.
Yeah.
All right. See, like that. You did something, right? And what does it say? It says 3 decimal places, right? Everybody good there?
Yeah.
Any questions on part A? That would most likely, if this was this is basically what a free response question might look like, that question would probably be worth only 1 point. So you get 1 point out of 9 for that. All right, so part B is asking us to look for, or to use h of x, which is f of g of 3x, and we want to find h prime of 0, is that correct? H prime
Yeah.
of 0. Okay, so we are looking first off for the derivative of h. So we need to figure out what is h prime of x, and then once we find h prime of x, we're going to evaluate it at 0. So what do we have here? We have f of a function, right? We have a composition of two functions. We have f of u with u equal to g of 3x. So how do we take the derivative of a composition of two functions? We use which rule?
Chain rule.
Chain rule. So it should be the derivative of the outer function. So what's the outer function? Is the outer function f of u, or is the outer function g of 3x?
F of u.
For view.
F of u. So what's the derivative of that? That should just be f prime. And we evaluate that at g of 3x. And then we have to multiply by the derivative of g of 3x. So what's the derivative of g of 3x?
3g prime 3x.
Yep, should be 3g prime of 3x. And that 3 comes from, this is like g of v with v equal to 3x. So we take the derivative of the g prime of that 3x, and multiply by the derivative of 3. So it's a chain rule within a chain rule, even though we're not even given a single function to look at. Does that make sense?
When I was
Yeah.
trying to do this one, I try to like figure out what, like an equation for g and an equation for f. Is that just a completely wrong way to go about it? Because that's like impossible to do, or?
That is a completely wrong way to go about it, yes.
Cool.
Yep, you don't want to try and do that. They're giving you charts of values. You're going to use those charts of values, and they give you f prime, so you'll be able to evaluate f prime at any value you want. So yeah, you don't need to do that. All right, so now h prime of 0 should be f prime of g of 0. True, because if x is 0, then 3 times 0 is 0, g of 0. We'll figure out what g of 0 is from the chart in just a second. And then times 3 g prime of 0 again, right? Because 3 times 0 is 0. Everybody good with that so far?
Okay, yeah.
Yeah? Okay, so now we just need to go back and look at our chart and figure out what's g of 0 and what's g prime of 0. So g of 0 is 4, and g prime of 0 is -7. Everybody good there?
Yeah.
All right, so g of 0 was 4, so this becomes f prime of 4. And what did I say g prime was? -7? Is that right?
Yes.
Cool.
Yeah.
So now this just becomes -21 times f prime of 4, and f prime is also given to us. So we have -21 times 4 and times the sine of 16. And your calculator will tell you what that is. What does that come out to be? It's -84 sine 16, which is approximately what?
.24. Yeah,
24.184. So make sure that you round to at least at least 3 decimals, 24.184. If you want to go further than that and write out the whole thing off the calculator, that's great, but you don't need to do that. Any questions on part B there? You're going to want to get used to, and we're going to do a bunch of practice with stuff like h is f of g of 3x, find h prime of 0, of finding derivatives of things where you don't actually have a function where you just have to apply the rule to it.
And will that always be chain rule when you see something like that? You just immediately think chain rule right there.
Yeah, because you look at it and you say that's a composition, that's one function within another function, and that's 100% of the time going to be the chain rule. Now they may not give you a chain rule one, though. They may give you one that's, you know, a product rule. They may say h of x is equal to f of 2x times g of 5x or something like that, you know, and then you'd have to use the product rule and then the chain rule within the product rule for that. Does that make sense?
Yeah.
Yeah, so I mean, and we'll practice some of all the different types. The chain rule ones are probably the more complicated ones of them, but you'll see all different types of it. So we're going to do part C now. So part C is asking us to write an equation for the line tangent to the inverse of g at x equals -1. So if we're looking for a line tangent to the inverse of g at -1, what rule do you think we're going to use that we've talked about recently?
Inverse rule.
The
Yeah, we're gonna
inverse
use
rule.
the inverse rule, right? So, okay, so we're looking for g inverse at -1, right? So we know that g inverse is going to have a point -1 comma something, which tells us what about g? G needs to have a point that is something comma -1. Everybody agree with that?
Yeah.
Okay, so
Yeah.
and we're looking for a tangent line equation, which means we need two things. We need a point and we need a slope. And so our slope is going to come from the inverse rule, and our point we'll find from this chart of values on g. So if g is something -1, we should be able to go back and look at the chart and say, when does g equal -1? Well, that's when x is 2, right? G is -1 when x is 2. Everybody agree with that?
Yeah.
So now we know that we now know those 2 points. And if we are looking for the, like I said, looking for the tangent line to g inverse at -1, that should be then equal to, or not equal to, but the reciprocal of the slope of g at 2. So g inverse prime at -1 should be equal to 1 over g prime at 2. Everybody agree with that based on our inverse rule from the other day?
Yeah.
That's using like the
Yeah.
A right there for the -1, and then the B's the 2. Is that what the inverse rule, right? Just confirming.
Wait, say that again?
That the -1 is like the A of it, and then the
Correct.
2 is the B of it.
That's correct. Yep.
Okay.
Yep, 100% correct. So we just need to figure out what's g prime of 2. So once again, we'll go back to our chart. G prime of 2 is -3. So this is 1 over -3, which tells us that the slope of the line tangent to g inverse at x equals -1 is -1/3. So that's the slope we want to use. And if we're talking about the point for g inverse, what's the point we're going to use?
-1, 2.
-1, 2. So it should be in point slope form, y minus 2 equals -1/3 times x minus -1 or x plus 1. And you don't need to convert it into slope intercept unless the problem asks you to. And I don't believe it did. So that should be a good answer. Any questions on that? All right, so now we're going to look at part D. Part D gives us a brand new equation, f of x plus g of x squared equals xy. So this equation is defined implicitly, right, because it's got x's and y's in it. And we're looking for the value of dy dx at 1, 4. So let's write out this new equation. This is f of x plus g of x squared equals xy, and we're interested in the slope of the tangent line. What was the point 1, 4? So if we're looking for dy dx, we need to differentiate both sides of this equation with respect to x. So what's the derivative with respect to x of f of x?
F prime of x.
F prime of x, right? And that's all in terms of x. F is a function of x. So when I take the derivative with respect to x, I get a function in terms of x. And I don't have to attach a dy dx to it because there's no y term there. What about g of x squared? G is also a function of x. So this is just u squared. So that should become what?
2g prime x.
Not quite. So if this is, let's write this off to the side. This is u squared with u equal to g of x. So it needs to become 2u times g prime of x using the chain rules. Everybody see that?
Oh,
Yeah.
Yeah, so 2u, where u is g of x, so 2g of x times g prime of x. Good or no?
Yeah.
Okay. Try and move this over, so that's not going to work, is it? Oh well. I was trying to give myself more room. What about the derivative of xy? We've done that one a bunch of times implicitly. Hopefully you've just kind of got to the point where you have that memorized now. But it's x dy dx plus y. Good or no?
Yeah.
All right, so what does dy dx equal? It equals f prime of x plus 2g of x g prime of x minus y all over x. Everybody agree?
yeah.
All right, and then the last thing is they just want us to evaluate that at what point? The point 1, 4. So we're looking for f prime of 1 plus 2g of 1 times g prime of 1 minus our y value, which they gave us that point, so minus 4, all divided by our x value, which is 1. Everybody good or no?
Yeah.
All right, and I believe f prime was equal to x sine of x squared. Is that correct?
Yes.
Yep, so if f prime of 1 then will just be 1 times the sine of 1.
What?
Or just the sine of 1 plus 2g of 1. So what's g of 1 from our chart? G of 1 should be 2.
2.
And g prime of 1 is negative 2. So g of 1 is 2. G prime of 1 is negative 2. Minus 4, and then all over 1. So we've got sine of 1, and then we've got minus 8, minus 4. And if we take a look on the calculator, we should be able to approximate that, which is what it asked us to do. Sine of 1 is that, minus 12 gives us negative 11.159. Any questions on that, or everybody okay with that?
Would this be considered like a easier free response question or harder, or like where on the hardness spectrum does it land?
I would say that it is between easy and medium. I wouldn't say that this is a difficult one, mostly just because we haven't really covered any of the difficult stuff that we're going to cover this year. I would say this is relatively straightforward. Does that help answer your question?
Yeah, I'm just trying to get like a general idea of.
Yeah, you may not like that answer because it probably seems fairly difficult at the moment.
Well, it's just
because
like
it's the first
figuring
one we've
out
done.
how to approach the problems. It's like once you realize how to approach them, that just everything falls into place and it's just math from there. But
Right.
Yeah,
and by
let's
the
just
time
I have no idea how to approach them, and you can't go anywhere from there.
by the time May comes around, we'll have done 15, 20 problems that are very similar to this, and you'll look at it and be like, oh, I know exactly what to do with this, and you'll just go through and hopefully not make a stupid mistake, and by May this will seem really easy. Right now, it's the first one we've done. Doesn't seem so easy because you haven't seen anything like this yet, but it will.
Yeah, I think I was just really stuck on, in order to take the derivative of something, you have to have a defined equation. And I was just sitting there like, what in the world am I supposed to do here?
Right. And one of the things that we all need to sort of keep in mind is that if we don't end up having the AP test in person, on paper where you're actually writing stuff out, a lot of the questions are going to look more like this, where they're more conceptual, where they don't really require you to have a function where you take a derivative of it, where it's just charts where you plug stuff in, or where you have to use the rules on just other basic functions, because they're trying to look for ways where they can assess if you understand the concept of it without seeing if you can actually take the derivative, because it's kind of a waste of their time to see if you can take the derivative. If you're sitting on your computer taking the test, you can punch it into any number of online derivative calculators and get the derivative without knowing how to do it. But you can't do this problem by just punching stuff into a website. You got to actually understand the concepts and the rules to do it. A little more conceptual. Any other questions on this one?